Okay, so we are doing section 12.6, permutations and combinations. These are going to be calculators. We're going to learn our calculator with the P button, and for combinations with the C button. So make sure you have a calculator if you do not yet. Our first bell work is just to multiply that. Of course, we're not going to do that by hand, right? So 7 times 6 times 5 times 4 times 3 times 2 times 1. I get 5,040. So that was a lot of work to type that in. So we are going to learn a new button on our calculator. I'm going to show it to you right now. It is called a factorial. Okay, if you saw what I just did there, you click the probability, PRB for probability, you're going to get these different options. This is going to be permutation, combination, and this little exclamation point is called a factorial. So if I was to do the same problem, hitting 7 first, probability going to my exclamation point, and hitting enter or equals, I would get that same answer. So it's a little quick way to type that factorial into your calculator. Okay, so counting methods. These can be used to find the number of ways to arrange or select objects. And our first concept here, this will be our first main one, is called the multiplication counting principle. If there are m ways to make a first selection and n ways to make a second selection, then there are m times n ways to make the selection, both of them. So our first example, we go to buy an ice cream cone at a local shop. Suppose there are 6 different flavors and then 3 types of cones, okay? How many single scoop ice cream cones could you order? Many of you probably do not need to know this, right? But in case you wanted to know, you are going to be multiplying those 2 options together. Our flavors, we have 6 of them, okay? Our cones, we have 3 of them. That means there are a total of 18 possibilities. Okay? Now, again, if you were to think about this, let's say one of my flavors was a chocolate. Let's say there are 3 types of cones. That would be 3 different selections. So for 6 different flavors with 3 types of cones, there's 18 different ice creams that you can order. Next type of example, our second one is, we're not there yet, my bad. We're still sticking with factorials. So again, I already told you what that symbol looks like. It is the exclamation point. So multiply all numbers from n down to 1. That is what we did up here for our bell work, correct? So our first example, batting orders. If you play baseball or softball, there are typically 9 batters in a batting lineup, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, and I'm gonna put the 9th one there. I have 9 slots, okay? So let's say, for example, that on my baseball team this year, let's say Danny Lopez was batting first, okay? He would go into this first slot, and there's lots of other people that are behind him. But on my team right now, I have 9 players. 9 players, so that's the other important thing, okay? So if I have 9 players, in this leadoff position, this very first slot, I have 9 people. 9 options that can go into that first slot. I just told you guys that I was going to go ahead and put Danny Lopez, okay? So if Danny is in that spot, Miss May, how many more players do I have on this team?
Well, one's gone now, so only 8.
Correct. So our next slot is going to be 8. 8 players that can go there. But let's say I go ahead and put Skylar, right? Skylar's there. Danny's there. I now have 7 remaining options. So as you see, as you continue to go down the batting order, it continues to decrease by 1. Okay, so this, again, you don't want to type all of that into the calculator. We're going to use that fancy button called a factorial. Okay, so 9 probability exclamation point equals. That is 362,880. That is a ton of different batting orders that can be made.
Wow.
Okay? So, again, that was 9 players with 9 positions to put in an order, so we use 9 factorial. Okay, so on the back side, the next type of problem we're looking at is the permutations, okay? So that's the symbol P on your calculator, and again, this is how it will look on the calculator. NPR. This is an arrangement of objects in a specific order. This can be used when you do not need to arrange all of the objects, all right? So going back to the similar problem from the front, if you remember on the front hand side, I had 9 players and we're putting 9 of them into a batting order. But let's say, in reality, I have 16 players with 9 in a lineup. So Miss May, what is different about this problem than the first problem?
Well, now you would have 16 of those.
Correct. I have 16 players. Were 16 of them going to play?
No,
No.
only 9.
Only 9, okay? So that is when we use this formula. So here, N is my 16 players, and 9 would be my R, okay? So if you see that side note right here, N objects arranged R at a time. I had 16 players, but I'm only gonna place 9 of them. That's when we would use this. So if I was to do the same problem here, let's just check that out and see how that looks. I'm gonna hit 16, probability, the P button, which is already highlighted, 9 in the order. Wow.
Wow.
That's a lot more options now. Again, instead of our original 9 players, we now have 16 to pick from. Okay, so that's how the two are connected there. Next example, we have a band has 7 new songs and we want to put 5 of them on a demo CD. So 9 total songs and we're gonna place 5 of them. How many arrangements of 5 songs are possible? Let's start with finding our N and our R. Miss May, how many total songs do we have?
7.
Right, and we are going to be picking how many?
5.
Perfect, okay? So again, how this should look on with the symbol NPR, it should be 7, 5. So you'll be doing similar problems like that on the homework, all right? We're going to calculate that. 7, probability, the P button, and we wanted 5, and we should be getting 2,520. All right, any questions on that?
Do I need to show any work?
You would not need to show work. There is a formula, right? This is a formula here where we could place in our numbers. Miss May, do you want to see what that looks like?
No, I'm good.
No. We are just going to use our calculator, but the biggest thing is being a P for permutation, or the next one, which will be a C. Okay, we're going to take a break there. Okay, and our third and last type is going to be a combination. The difference here is this is a selection of objects when the order does not matter. So if you remember with the baseball team, they have to be a specific lineup. With the songs here, they had to be first, second, third, fourth, and fifth, correct? But not all things have to be in order. That's what we're looking at here. So again, this is what you will see on your calculator. If you ever use the formula, this is your formula. First example, 20 people report for jury duty. How many 12-person juries can be chosen? Again, the order does not matter. They're just picking 12 of them. It doesn't matter who got picked first, who got picked last. There are 12 of them, and that means that is a combination formula, okay? So our N will equal 20 people. Our R will equal 12. We are going to be using the combination. Our N will be the 20, and our R will be 12. And then we are going to pull out and use our calculator. So 20 probability. I don't want permutation. Click it over. Now you see the NCR. 12 equals 125,970. So what we are looking for is bare minimum this on our homework. We need to see that it's a permutation or combination. The answer, you could write that down in addition, but this is the bare minimum on the homework, what we're looking for. Break.